This tutorial is show how to fit patchy bilayers or patchy areas of a system where over the entire surface of your interface you may have one area covered with one structure and another area covered with another structure. So if you have one area covered with, say, a lipid bilayer and one that wasn't coated, how would we analyse that data set? I'm going to show you from this currently existing structure. This currently existing structure consists of a fronting medium which is silicon. It's got an SLD of 2.07. Which is then followed by silicon dioxide, that's the native oxide, then an inner leaflet for the lipid bilayer, the outer lipid leaflet here, followed by the backing medium, which is in this case D2O. Right, to convert this to a multi-area model, all I have to do is right-click on a structure. I've selected a structure, right-click, then click on Mixed Area, Add a Structure. You'll see if I re-expand the model then for this contrast, you'll see then that there are two structures and that they'll look identical. And the scale factors for the model, there's now more than one scale factor, there's actually two scale factors. And those two scale factors represent the relative amounts of this first structure and the second structure. So you get half of this one and half of this one. If I changed it to say 0.6 for this one, then the overall scale factor would be about, say, 1.1. And 6/11ths would be the first structure and 5/11ths would be the second structure, and so on. Right, now say that in order for this to make any sense in this example, what we're going to do is actually say that the second structure has no lipid bilayer. It's just silicon dioxide, native oxide against D2O. So what we do is we select the inner leaflet, we click on minus, which removes the layer. You can also press Control or Command minus, which will also do the same thing. And now we have two different structures describing this interface. We have this first structure with the inner and outer leaflet on, that sits in between the native oxide and the D2O, or the backing medium. And then in the other part of this, the system, we have simply silicon dioxide against D2O with these different scale factors. Now when we analyse this data set, what we'd have to do is make sure that the parameter constraints are set up. So in that case, I've selected the two silicon dioxide thickness, right click, link parameters. You can also get to that by clicking on Model, Link Selected Parameters. There's also a shortcut for those of you who are good with keyboards. And then we will do the same thing with the roughness parameter of the silicon dioxide and the volume fraction of solvent in that silicon dioxide layer. And I also want to change make sure that the solvent is the same in both of those. When you do a linkage, it's the master parameter for those link parameters is the one that you first select. So now you'll see that the second structure consisting of the empty bilayer, the empty surface, is slaved to the first structure in as much as that the silicon dioxide thickness, roughness and solvent penetration are the same for both the coated area and the uncoated area. And the coated area and the uncoated areas are parameterized by these two scale factors, which will allow to vary. So let them vary, say, between 0.01 and 1.1. I'll just save the experiment to make sure we can get back, and then click on Do Fit. So you see chi-squared decrease. Getting better and better. $290 is pretty good for a data set which only has 146 points in total. So after that we get a nice fit. The scale factors are 0.84 and 0.16. So that's 0.84 of the first data set and 0.16 of the second data set. Sorry, not the second and first data sets, of the first structure and the second structure. But you'll notice that the uncertainties there are really large. In fact, this is a really good bilayer, so it's not really justified to use a mixed area because it's pretty good coating overall. It's not really justified to use this second area, but for the purposes of a demonstration, it will do. This column here is the uncertainties, and you can also see the parameters come out in the console at the end here, where we can see what the scale factors are for the relative two amounts.